Welcome to lesson 3.5, as today we will look at finding derivatives of inverse functions. You should have learned inverse functions in your pre-calculus course. And at the right, I've given you a graph of the function f of x, that's this one here, and its inverse, which is this one over here. And remember that if the graph of f contains a point a comma b, a of course being the x value and b the y value, then the graph of the inverse must contain the point b comma a, right? You switch the x and y around. Also visually, the inverse graph is always the reflection of the graph of f across this line y equals to x, right? That's why we always think it's switching x and y. So from the graphs, I'm going to ask you to see if you can find the relationship between the slope of the graph at AB. So this slope in red versus the slope of the graph of the inverse at B comma A, this one. What do you think is the connection between the slopes, which of course is the derivative? So maybe that's a little bit hard to see, so let's take a look at an example where I'll give you an actual function. So let's f of x be equal to the square root of x. I want you to sketch it, then I want you to find the inverse, and then I want you to sketch that as well. So hopefully you remember this is the square root function, 0, 0, 1, 1, 4, comma 2, and a nice curve that's like a sideways parabola. There's my f of x function. To find the inverse, we're going to switch x and y, so x equals to the square root of y. I'm going to solve for y, so I'm going to solve for y by squaring both sides. And therefore, the inverse here is equal to x squared. But remember, I must have a domain restriction. It's not all real numbers. This has to be bigger or equal to 0. So if I were to graph out this now, and I'll do that in blue, this is y equals x squared, so 0, 0, 1, 1, which makes sense, right? Switching around. 4, comma 2 now becomes 2, comma 4, and I get this lovely graph. And once again, not the other side of the parabola, don't do that. I have my domain restriction, x is greater or equal to 0. Okay, so we've done parts A, B, and C. Bravo. And now it's time to differentiate. So we have our function f of x, which is just root x, and I'll write that as x to the power of 1/2. And we have our inverse function, which is x squared. I'm going to ask us to find the derivative of each of these. So the derivative of our original function is 1/2 x to the negative 1/2. The derivative of the inverse, so how do I show that notation? Here's the inverse. We're going to find its derivative to the prime of x, and that is just equal to 2x. Alright. Let's actually pick a point now. So let's take a look at the point 4, comma 2 and 2, comma 4. So at 4, comma 2, I'm saying let's look at this particular tangent line. And at 2, comma 4, I'm saying let's look at this particular tangent line. And let's see if we can find the relationship between the two. So here we go. F prime of, this is the red graph, so I want the x value of 4. 1/2, 4 to the negative 1/2, that's 1/2 times 1/2, a quarter. And the inverse derivative evaluated at its x value, which is 2. 2 times 2, that's 4. What's the connection between 1/4 and 4? And if you said that they are reciprocals, then you just answered question F. They are reciprocals. And if you think about this, just think about this. What is inverse again? Switching x and y. So since the slope is really defined as the change in y over the change in x, it should also make sense that switching x and y for the inverse function should produce reciprocal slopes for the inverse. So that'd be delta x over delta y, or in this case, the reciprocal. So to formalize this, and I guess I would ask you to memorize. Yes, in AP Calculus, lots of stuff to memorize. That if you have a comma b, and it's a point on the original function graph, and then you have a point b comma a, which is on its inverse, then what I'm saying is that the derivative of the inverse, so that's this notation here, okay? The derivative of the inverse at x equal to b. Now remember, this x is the inverse is x, okay? Just to let you know, that's the same thing as the y value of the original function. Okay, so the derivative of the inverse at x equals to b, when its x is b, is equal to 1 over f prime of a. So this is really the reciprocal of the derivative of, not the inverse, but the original at what though? At its a value. So at x equal to a of the original is really the y value of the inverse. Okay? And if you understand that, this is actually pretty straightforward. Or if you like to use the function notation and say f and g are inverse functions, then the g prime of x, which is the inverse's derivative, is 1 over the derivative of the original, or the function, evaluated at g of x, which just happens to be the y value. So this g of x here, right, was that? That's the y value of the inverse. Okay. And this last note here, derivatives of inverses have reciprocal slopes at image points. So those are the points reflected across the line y equals x. A comma b, and then of course b comma a are image points. Okay? Just be aware, the difficult thing here and the tricky part is when finding derivatives of inverses, do not use the same x value for both f and f prime. Now you could, because it does work in one small scenario, and that scenario of course is when the x and y values actually are the same, but most of the times your questions will not be like that. Okay? Now let's look at example number 2 then. So here I've got two functions, f and g. They are inverses, such that f has the function and derivative values shown in the table. So in this one I didn't give you the actual equation, but I gave you the table and some data from a table. So from the given information, can you find each of the following values if possible? Now, I like actually organizing information in a table, because I think having the information in a table really helps us understand what's going on, and then we can quickly actually pluck off our answers from this chart. So if I were to just look at this information here and look at f of x, I've got points, right? I've got points on this graph. When x is -1, the point or the y value is 1. And now my question here is, what is the actual slope? M stands for slope. Okay, so what's the slope at that particular point? Yes, the chart or the table says 3/2. So can you fill in the other two things for me? When x is 0, what do we got? The y value is 2. Good. And the derivative is 2. Good. Finally, when x is 1, the y value is 5. And the slope is 1/2. And this is all for the original equation. So now if I want to find g is the inverse, well, how do I do that? Well, for the points, guess what? I switch x and y, right? So instead of having -1, 1, it becomes 1, -1. And what about the slopes? Instead of having the slope as 3/2, I do the reciprocal, so it's actually 2/3. Similarly for the other ones, okay, 2, 0 now, and the slope is 1/2. And then finally, not 1, 5, but 5, 1, and the slope here is actually 2. And so now once you have this information, I think it's really quite simple now to answer the questions. So what is g prime of 1? Well, here's g prime, that's a slope at 1. At 1, the x value of that point is 1. Well, that's just 2/3. Done. So try the next one. What's g prime of 2? I hope you said this is 1/2. Oops, don't need highlighter. What about g prime of 3? Oh, that's a problem because I don't have 3. I have 1, I have 2, I have 5. I don't have 3. So really, it doesn't mean there's no answer. It's just it cannot be found. Cannot be found. Okay. Same thing with g prime of 0. It just cannot be found. I just don't know what it is because I only have a limited amount of data. Cannot be found. And finally, g prime of 5. Yeah, that can be found. That's equal to 2. Okay. All right. And one last example here with actually a function before I let you try some questions from the assignment. Here I have f of 3 equals to 28. And I'm having the function given as x cubed minus 2x plus 7. I want you to find the inverse of this derivative evaluated at the value of 28. So how can we do this? Well, if I'm looking at that chart thing, I have a nice coordinate 3 comma 28, right? And the question is, what is the slope at that point for the f graph, or the original function? Well, I better go ahead and actually find the slope, which is, oh yeah, 3x squared minus 2. And then I better plug in what value here? 3, right? F prime of 3. So 3 squared minus 2, that's 25. So really, at this point on the original, the slope is 25. Okay? So once you got this, then like I said, with that little chart, I said, hey, can you find the corresponding g value now? Well, the coordinate would be 8 comma 3, right? We're going to switch them around. And what would be the slope? Yeah, it's just the reciprocal, 1 over 25. So now when I ask you for f negative 1, which is the inverse is prime, the derivative at 28, well, you can now quickly tell me what this is now. It's just equal to, you got it, 1 over 25. Okay? Now, if you want to use the formula on the previous page, remember, this is the same as 1 over the original's derivative, evaluated not at 28 though, but at the other value. What is the other value? Yeah, it's 3. Okay, so you can use this formula from that box on the previous page, or like I said, I think making a chart like this, pretty cool. And it works. Okay, that's it. Get to work. Practice, practice, practice.